What does the future of space exploration look like? And will Mars one day be able to support human life? Well, scientists think so. This week on Full Frame, we take a look at how both the public and private sectors are using science and technology to find out if the people of planet Earth can someday be part of the Red Planet. I'm Mei Lee in Los Angeles. Let's take it full frame. Andy Weir is a self-described space nerd who didn't realize his writing and sense of humor had mainstream appeal until it landed him a book deal in 2013. Almost instantly, it transformed him from computer programmer to best-selling author. Now, since then, his novel about a risky manned mission to Mars has gained the attention of scientists at NASA, reignited the public's fascination with space travel. And his book, The Martian, might sound familiar, has been on the New York Times bestseller list for more than 60 weeks. Wow. Praised for its scientific accuracy, The Martian was also adapted into a film directed by Ridley Scott and starring Matt Damon. Now, the movie won 2 Golden Globe Awards and an Academy Award.
At around 4:30 a.m., our satellites detected a storm approaching the Ares 3 mission site on Mars. The storm had escalated to severe, and we had no choice but to abort the mission. But during the evacuation, astronaut Mark Watney was killed.
I'm entering this log for the record. This is Mark Watney, and I'm still alive. Obviously.
Great movie. Well, joining us now from Mountain View, California, is the author himself, Andy Weir. Andy, welcome to Full Frame. So glad to have you here.
Hi, thanks for having me.
Well, Andy, first of all, congrats on the book, because what an amazing achievement. 60 weeks on the bestseller list, New York Times, and now it was made into a movie, 2 Golden Globe Awards, Oscar nominations. I mean, this must be a shock to you in so many ways.
Yeah, I really have no idea what I did right. So, we'll see if I can do it again someday, but I'm enjoying the ride.
Well, you should, and it seems to keep going right now for you. But let's go back to the origins of the book. What I find interesting is that, really, you were just writing this for fun, about Mars exploration. First of all, why Mars? What was the fascination for you?
Well, I've always been a space dork my whole life, and Mars is the next obvious place for us to go. I mean, we've been to the moon. Venus is hell. It's just, it would take another century of technological development for us to be able to put humans on the surface of Venus. So Mars is the next obvious place to go. And I think there's just a general fascination with it. It's exciting. It's in the popular culture. There's lots of fiction around it. It's a thing space dorks like.
Okay, I love the term space dork. It's very technical, isn't it?
Yes.
Well, so you originally self-published the book, right? And then you put it online for people just to read it for fun, in increments. But then you had 3,000 people regularly reading this. And then all of a sudden, Crown Publishing came to you and said, we want to publish this as a full book. What was that like for you?
Well, there was an intervening step where I put it up on Amazon, self-published it, and was forced to charge at least 99 cents because that's the minimum Amazon allows. And it sold really well on Amazon, and then Crown took an interest because it was like a proven seller. It was amazing for me to be approached by a print publisher and told, like, hey, we want to make a book out of your story. And
right.
It had been all my life. I've wanted to be a writer. The Martian's actually the 3rd book I wrote. It's just the first one that doesn't suck. So I'm really happy that I finally landed a publishing deal. I've always wanted to break into the industry.
Let's talk about the main character, Mark Watney, who Matt Damon plays the main character. Did an amazing job in that. Won a Golden Globe for Best Actor, obviously. But he's kind of a smart aleck, has a really good sense of humor, but also knows how to survive. What was it about this character that you shaped in this way? Why?
Well, a couple of things. First off, he's based on my own personality. I mean, I'm a smart aleck myself, and I'm a science dork just like him. He's the idealized me. He's me without all my flaws, right?
Okay.
So he's what I wish I were. And the reason I made him so snarky was because I had to do a lot of exposition in the book. I had to explain a lot of scientific principles. It would have been really dry. It would have read like an encyclopedia article if I didn't have a bunch of jokes and gags in there. So having him describe it in a funny way helped get all that exposition across to the reader. And it also helped, like, make the reader care about him and like him.
Yeah.
I think it worked out pretty well.
No, it really did. You're right. You're right. Because of his attitude and personality, it made it more understandable, and you could relate to him a little bit more. Let's take a clip from the movie when he's being shown in this particular clip. We'll take a look at it, and then we'll talk about it on the other side.
Right. Let's do the math. Our service mission here was supposed to last 31 souls. For redundancy, they sent 68 souls worth of food. That's for 6 people. So for just me, that's going to last 300 souls, which I figure I can stretch to 400 if I ration. So I got to figure out a way to grow 3 years worth of food here on a planet where nothing grows. Luckily, I'm a botanist. Mars will come to fear my botany powers.
What amazed me about this book, and a lot of scientists have said this also, the scientific accuracy and the detail in this book about what life would be like on Mars and how people would survive and what they would do in order to survive. How did you even begin to get all that information together to make it so accurate?
Well, it starts with a lifetime of being a space enthusiast. I mean, I'm just into that stuff, so that was always my hobby. Second off, I just did tons and tons of research because I really wanted to be accurate, because as a science nerd myself, I know that it really takes you out of the story if you understand science and then see violations of physics in a story. Right. So I was writing it for my mailing list. I was writing it for my blog readers who were hardcore science dorks like myself, and so I wanted to make it something that they could enjoy and something that I would enjoy. So, yeah. I spent. Also, it helps to have no social life, so you have plenty of time to do research. That's helpful.
Right, okay, so you had a lot of time on your hands to do this. But honestly, Andy, what's amazing about your book and the movie is that even NASA has said that this is incredible. He's so accurate that they would have wanted to write something very similar if they had the opportunity to write about Mars exploration. That must make you feel pretty good, because remember, you're not a rocket scientist, you're a computer programmer.
Right. I was thrilled to see NASA's response. I thought they wouldn't respond at all or would be kind of aloof, but they've been enthusiastic fans of the movie. They invited me down to Johnson Space Center, and I spent 4 days getting VIP tours. I got to go into the Mission Control Center. It was awesome. It was great. It was the greatest week of my life.
Is there anything that you would have changed? For instance, now we are saying that there is water on Mars or some sort of water source. At the time when you were writing this book, that hadn't been discovered yet. So would that have changed the story at all for you?
Yeah, absolutely. When I wrote the book, people thought Mars was completely dry and arid except for the poles. Right. Now, once Curiosity landed there, which was after I wrote the book, they found out there's an enormous amount of water in the soil, about 35 liters for every cubic meter of soil. So in other words, if you were to fill your refrigerator with Martian soil and then extract all the water from it, you'd have 35 2-liter bottles full of water. It's just there's huge amounts of water trapped in the soil. So all the stuff the protagonist had to do to create water, which was this complicated chemistry and very dangerous stuff, he didn't have to do.
Wow,
he could have just brought dirt in and heated it up.
Well, let's take a look at another clip where NASA is planning on trying to conduct this rescue mission. Let's take a look.
Okay, let's pretend that this stapler is the Hermes, and you are...
Teddy. I'm the director of NASA.
Cool, Teddy, you're Earth. And right now, the Hermes is headed towards you, starting its month-long deceleration to intercept. But instead, what I'm proposing is... we start accelerating immediately. to preserve velocity and gain even more. We don't intercept with Earth at all, but we come close enough to get a gravity assist and adjust course. While we're doing that, we resupply with the probe.
Food and supplies.
Pick up whatever provisions we need, and now we're accelerating towards Mars. Shh. You're Mars. Now, we're going too fast at this point to fall into orbit, but we can do a flyby.
Watney would intercept using the MAV.
And then we just head home. I done the math. Checks out.
Rich?
Yes, sir.
Get out.
Again, Andy, I mean, this is a complicated mission that they're mapping out. And, you know, a lot of folks might be like, that can't really work in real life. But again, this is very accurate, right? You did the math and you did the research.
Yeah, I wrote software to help calculate the orbital trajectories and everything for Hermes, which was really complicated, too complicated for me to do with straight math. I had to do simulation.
Okay.
And I got it, and the math does check out. And actually, after the book came out, there were real orbital dynamicists who, Rich Purnell, the guy describing everything, Donald Glover, in that scene, is an orbital dynamicist. And I've had real orbital dynamicists say, like, oh yeah, we checked all your numbers, and we checked out the orbital paths of Hermes, and you're very close to right. You're like within 2%. And so I feel pretty good about that for being a rank amateur.
You wanted to make this so accurate that there wouldn't be any criticism, because we do see a lot of science fiction movies, space movies, and people the experts rip it apart, saying, no, there's no way that could happen. That's totally inaccurate. But for you, it all checked out.
Well, not all of it. There are a few errors in there.
Oh.
But,
oh, really?
Oh, yeah.
Okay. All right. Well, you can keep those secrets to yourself. But let's talk about your reaction to this movie, because oftentimes when books get made into movies, the authors aren't happy with the result.
Well,
how did you feel?
That's not the case here. I'm thrilled. I think they did a fantastic job. It's very true to the book, which of course I like. And then it's just great. There are a bunch of things where they enhance it and made it so much better. For instance, that scene that you just showed, that was in the book. That information was conveyed through a series of meetings at NASA and a bunch of different expositions, but they didn't want to do that in the film because it would get boring. And so Drew Goddard came up with that whole scene showing where they used the stapler as an example and stuff. And that was just a beautiful, elegant way to describe things. Also in the book, it's the first-person narration. It's just Watney's log entries, and they didn't want to just have a voiceover narration through the whole movie, and that's where they came up with the idea of the video feeds from all over the place, and so he's just like talking to the video cameras because he's documenting what he's doing because he's an astronaut.
Right. So makes sense.
That plus, finally, Ridley Scott is just a master of landscapes and sceneries and panoramas. Yeah, that's almost a trademark of his. The gritty cityscape of Blade Runner or the deserts in Exodus. I mean, just any Ridley Scott movie, you can expect to find these tremendous landscapes. And just to see his rendition of Mars was just awesome. I just loved it. Because he can't really describe scenery in a book, not without boring the reader.
What I also found interesting in the story is how China ended up playing a part in this rescue mission, and pretty integral part. Was that something that you wanted to consciously put in there as a way in which that space exploration can be a cooperative global effort?
Well, absolutely. I mean, well, first off, I never have any political point or agenda when I'm writing. I just want to entertain. However, I think that China is ascendant in their space program. I mean, the Russians aren't really inventing much new. They have a new Soyuz coming up. Our manned space flight is off for the moment. We're working on a new one, kind of silly, but China is actually doing new things. So I'm really interested in them. I hope they follow through with their plans to do a manned moon landing, and if they do, I hope they air it live so my generation can get to stay up all night and watch people walk on the moon. That would be awesome. And I really think we should be cooperating with China in space travel. I mean, we did joint missions with the Soviets at the height of the Cold War, so it's not a strategic or military issue, right? I feel like I don't understand why NASA and China, it's Congress that prevents it, and I don't know why.
Well, speaking of exploration to Mars and getting humans over there, why do you think it's so important to try to do this? I mean, why not just continue to send robots and unmanned missions to Mars?
Well, it's all about your objectives. If you're trying to learn about Mars, if your objective is, I want to know the science behind Mars, I want to know about its geology, its history, whether or not it had life, what its atmosphere was like a billion years ago, that sort of stuff, then there's no reason to send humans. You can do all that with robots.
Right.
Humans would do it more efficiently, but robots do it without risking human life, and it's a hell of a lot cheaper.
Right.
The reason to send humans to Mars, in my opinion, is because I think we should eventually colonize Mars. So the purpose for sending humans to Mars is to figure out how to send humans to Mars. Because I and a lot of other people agree, would like mankind to exist on 2 planets. Because once we do that, we're virtually immune to extinction. While we're all on 1 planet, there's a chance, it's small, but there's a chance that we could be wiped out by a cataclysm, a meteor strike, a plague, a mass coronal emission or something, I don't know. But if we're on 2 different planets, our odds of extinction drop to pretty much 0. And after 25 years as a software engineer, I've learned the value of backing up my data.
Okay, thank you so much. It was such fun talking to you. Much more success to you, but man, you have done a phenomenal job with this book, and now the movie is a huge hit. So congratulations to you.
Thank you so much for having me.
All right. Well, coming up, Mars on Earth, how the Canadian Arctic serves as training ground for life on the Red Planet. We'll be right back. Pascal Lee has the coolest job in the world, literally. He spent the last 19 summers on Devon Island in the high Arctic. How cold does it get? Just minus 50 Celsius. As a result of his research there, Lee is the first person ever to suggest that Mars has always been a cold planet, and the science is proving him right. Pascal Lee is chairman of the Mars Institute, a senior planetary scientist at the SETI Institute, and director of the NASA Hot and Mars project at NASA Ames Research Center. He's written a great children's book called Mission Mars, providing kids with a playful and fun guide to packing for a human mission to the Red Planet and what to do once you arrive in sub-zero temperatures. Very important. Lee is also one of the very few people on Earth who can tell you what it's like to wear the latest model spacesuit and drive vehicles custom-made for places like Mars. These are suits and vehicles that may be the everyday norm for future generations of humans. That looks like fun. All right, Pascal Lee, welcome to the show.
Thank you.
Great to
Good to
have
be
you here. Yeah, I first need to find out, what is the fascination with Mars with you? Has it been a fascination since you were a kid, or how did this all come about with you?
Yeah, I mean, I think that if you step back and look at the big picture of space,
Yeah.
if we were like an alien civilization coming into the solar system for the first time, you wouldn't care about Mars. You'd fly past it, and you might take a picture. You'd go for the Earth, because the Earth is the happening place.
Yeah.
It's location, location, location.
Right.
It's not too cold, not too hot. It's got liquid water. It's got life.
Yeah.
And I don't think it's being geocentric to think that really the Earth is the gem in this corner of the galaxy, probably. But we are on Earth. This is our home. We're very familiar with it. And we are looking out into space. And Mars is interesting to us because it's so close to us.
Yeah.
It's the second closest planet to us. And it's the only one that's sort of, among these Venus and Mars that are so close to us, Mars is sort of farther out. It's colder than the Earth, but not so cold that you don't have liquid water. You can have liquid water on Mars. And you might have life there. And so we are interested in Mars just mainly because we're so curious about who we are.
Well, let's talk about Devon Island. Fascinating, because it really is, you say, the closest thing to Mars on planet Earth. And why is that?
Yeah, well, you know, no place on Earth is exactly like Mars.
Right.
But if you were to describe Devon Island, it's a remote, isolated island. It's the largest uninhabited island on Earth. It's cold, it's dry, it's rocky, it's windy. There's no vegetation to speak of that you can see. It's scarred by an impact crater. There's ice in the ground. There are ancient valleys that are carved by flowing water that's no longer there.
Sounds like a great vacation place.
But this description, well, I love it because I get the sense of going to Mars every year.
That's true.
But it's really how you would describe Mars as well.
Huh.
And so we have here on Earth this amazing place that is, at the very least, teaching us something about what happened on Mars, possibly.
Right.
How did Mars get its landscape? What happened to Mars over time? And might there be life in a place like this?
Okay, you were also involved in a documentary about what you do on Devon Island, right?
Yes, so...
called Passage to Mars.
Yes, Passage to Mars.
Right.
Passage to Mars is coming out in 2016, this year.
Okay.
The thing about this Devon Island place is that, of course, we go there for the science of the place. We try to understand it, but we're also using it as a set. As a set to learn how to explore Mars.
Right.
And so one of the things we do is to learn how we might explore Mars in the future with vehicles and people. I mean, should you go out, of course, never on your own, but what's a good-sized group of explorers? How many vehicles should you take on a one-week journey into the wilderness?
Right.
What kind of instruments do you need to take with you? So
that's pretty cool that you can kind of experiment just to see sort of how you might respond and react and what your needs are. We have a clip, actually, from the documentary,
okay.
so why don't we take a look at that?
Okay, sounds
All right.
good.
The crew's split up, food's running low. Maybe we've gone one step too far.
It has been a very humbling series of discoveries. We are trying to understand why we even exist.
As we make our way deeper into the Arctic, the feeling of roving on Mars grows stronger. How far on Mars? How deep into the planet will our search for water and life take us? As usual, when left to themselves, my thoughts turn to Mars and our search for life there.
We can land this thing up there. Land it? Sure, but we're not going to get it back off. That was heroic.
All right, that looks pretty harsh out there.
And it's nothing compared to Mars. Mars is going to be the mother of all camping trips.
Wow.
The average temperature is minus 60 degrees centigrade. The atmospheric pressure is very low, so if your spacesuit springs a leak, you basically die within seconds, and that's not fast enough.
But is it doable?
It's doable.
It's doable.
It's absolutely doable, and that's the beauty and challenge of it.
Yeah.
It's doable with, of course, a number of things that need to be worked on.
Right.
The spacesuit being a key element. Right now, the spacesuit that we have is too heavy. It's okay to use it in weightlessness in low Earth orbit around the space station. It's okay to even use it on the moon, where gravity is 6 times less than on the Earth. But if you take this spacesuit that we have to Mars, it's going to feel, it weighs on Earth 300 pounds.
Oh, wow.
If you take it to Mars, it's going to feel like it still weighs 125
pounds. So that's still pretty heavy.
That's too much.
Right,
50 kilos.
Are you working on that right now to try to adjust that weight?
Yes, we're working on ideas,
okay,
on technologies to make the spacesuit much lighter than the ones that we currently use, and yet as safe, if not more safe, and yet more capable as well. You have to think of a spacesuit not as clothing. It's a wearable spacecraft.
Right.
So
interesting.
It has computers on board, it has a life support system, radios, communication devices.
But you still have to be mobile. I mean, you have to be able to do stuff.
You have to be mobile.
Yeah.
You want to climb around, you want to pick up rocks, you want to look for life.
Well, let's talk about an actual mission to Mars. It's possible, but I know that there are a lot of dangers involved, including a lot of radiation exposure to the astronauts going and especially coming back. I mean, when they come back, are they going to be like glowing in the dark or have the most awesome suntan or something?
Well, you put the finger on the key safety issue of a human mission to Mars, which is radiation exposure. But in some sense, a mission to Mars is fraught with so many dangers that really, if the only thing that will ultimately kill you is a higher risk of having cancer once you're back on Earth because you were subject to some radiation, it's really, I think, an acceptable risk. But we can go over this real quick. The mission to Mars typically is 6 months to get to Mars.
Right.
And then in a typical scenario, you stay at Mars, on Mars, or around Mars for 18 months. That's a year and a half.
Okay.
That's because you can't come back immediately. You have to wait for the Earth and Mars to reposition themselves before you can fly back cheaply.
To be close enough to each other, right? Yeah.
Well, exactly. Well, in the right place for you to come back cheaply. Yeah.
Okay.
And then it's another 6 months to come back.
Okay.
So you spend about a year in total in deep space, going back and forth. And then a year and a half at Mars or around Mars. Anyway, the total dosage that you're going to get radiation-wise is similar to you undergoing something like 100 or 200 CAT scans. Now, that's a lot.
That's a lot.
Nobody undergoes 100 to 200 CAT scans.
Right.
But it's not even mortal. It's not something that would kill you. It's something that, could raise your risk of developing cancer by about 5% compared to the average population.
Okay. Okay. So you're saying that's sort of a minimal risk compared to all the other things that could possibly go wrong.
What is particularly dangerous is if there's a solar eruption. These are called solar particle events, a solar flare.
Okay.
And that could essentially represents a radiation storm for you. So for those moments, and they can last a few days typically, you want to be hiding in a well-shielded part of the spacecraft.
Okay, good tip for the astronaut.
Exactly.
But how would an astronaut protect themselves then from the radiation? I mean, are there ways?
For the day-to-day radiation, the best thing is to put between you and space stuff that contains hydrogen, and that's food and water. Food and water. Water is H2O, it's plenty of hydrogen. Food has hydrogen in it because carbohydrates, okay? Now, the good news about this, there's good news and bad news with what you want to do basically is line the walls of your spacecraft with your storage of food and your storage of water. So there's good news and bad news about that.
Wow, okay.
The good news is you drink the water, then you have to go to the bathroom, it turns into urine, but that's okay, you can recycle the urine. We already do that on the space station.
Yeah.
And a few weeks, so you don't take, on this 2.5-year journey to Mars with your crew of 7 people, you don't take all the water you need for everybody. You take only so much water, and then you recycle the water. So a few weeks into your trip, you are drinking each other's recycled urine and sweat.
Yum!
That's the good news. The bad news is the food, okay? We don't recycle food. We eat the food, we go to the bathroom.
Right.
And then food turns to...
I'm really afraid of what you're going to tell me right now.
Exactly. So what do you do with that? You can't just open a window and throw out your feces out into space. That's not good. First of all, you don't have a window that opens. Second, you don't pollute space. But the thing is, even your feces still contain hydrogen.
Okay.
Your feces have to be looked at as radiation shielding. So what you need to do is collect your human waste in a Ziploc bag.
No.
Emphasis on lock. And you put that bag back on the wall where you took it in the first place.
Pascal, no.
We don't do this on the space station because the space station right now is inside the Earth's magnetic field. So it's shielded from a lot of radiation. The astronauts do not have to put their poop back on the wall. But on a mission to Mars, you're in deep space.
Okay, that's all right. That's a very nice visual. Thank you so much for sharing.
That's if you want to survive and protect yourself from radiation.
Okay. What do you think? What's the time span, do you think, of when we might see a mission?
The current plan, as far as NASA is concerned, is to get humans to Mars orbit. So without quite landing yet, but to the orbit of Mars by the mid-2030s. And I believe that. I think it's in progress.
Less than 15 years.
It's less. Well, it's about that. Yeah, exactly. Exactly. It's about 15 to 20 years from now. And so I think that's eminently feasible, and we are on course, although extra funding would really help, and I think we should do that. But landing on Mars will take about a few more years after that.
Okay.
But going to Mars orbit will really get the ball rolling, I think. And so I see humans landing on Mars in the mid-2040s.
Wow.
So I'll be an older person, but I hope to still be around to see it.
Hopefully you'll be able to witness it. Wouldn't that be exciting?
Wouldn't that be exciting?
Yeah. Well, Pascal Lee, thank you so much for coming in. Such exciting stuff you're doing, and you really are a rocket scientist, aren't you? Man, that's impressive. Thank you so much.
Thank you, May.
All right. Coming up next, looking for life on Mars. It may be closer than you think. We'll be right back. Natalie Cabral is an alien hunter. She's a planetary scientist at the SETI Institute and the director of the Carl Sagan Center, where she searches for signs of microbial life on Mars. Now, she believes humans will live on Mars one day. Her research in the high Andes led to the discovery of a world record UV index of 43, which is more similar to the surface radiation on the red planet than here on Earth. Now, the recipient of numerous NASA and other research awards, she's also earned the nickname Mrs. Gusev for choosing to land the Mars Spirit rover at the Gusev crater in hopes of finding water. Recently, NASA confirmed her hunch and announced the discovery. Natalie Cabral joins me now on Full Frame. Great to have you here, Natalie.
Morning.
And talk about some great achievements on your part. That's pretty amazing that you actually were the one to discover that there was water at the Gusev.
Well, it's a long story. You know, the water was there a long time ago. Right. So it's not that we discovered the bucket of water sitting at the, at the surface of Mars. It's the sign that water was there and abundant in the past, which is really, really interesting when you're looking for signs of life.
But that must have been pretty gratifying for you when you found out you were right.
Well, you know, science is not about being right or wrong. It's about learning. And so, of course, it's gratifying when, you know, your hunch is confirmed.
Right.
But I guess that more importantly, it was a team effort. What was very gratifying, on the other hand, was to have spent nearly 10 years, you know, just looking at pictures, orbiter pictures, and from the top, from very high, at the Viking images, and one night, just having a panorama of that place that you have been looking at for so long, and from so high. And the first panorama, you know, at Gusev definitely is engraved right here.
Wow. Well, your current project right now at the SETI Institute, it's all about exploring past life on Mars, right? Tell me about what you're finding and, you know, what you're learning.
Well, as you can see with the series of missions that we've had, 10 years ago we sent a first orbiter to take images of Mars, and we learned about the geology. And there we wanted to understand, was Mars active? Was there water out there? What kind of information the mineralogy is telling us? And then there was another orbiter, and that one told us about climate, past climate and current climate. Was the climate favorable for, you know, the presence of water, for instance? So we learned a little bit more. And then once you had the geology and the climate, then you start having the data that is necessary to think about habitat and life potential.
Right.
And so we started preparing a mission, and that was the Mars Exploration Rover mission, to land on two places where we thought that water had been abundant for a long time on Mars. And so that was Meridiani and Gusev. And then, yeah, it was confirmed that Mars was habitable a long time ago. And now we're going, you know, we continue on this march, as you said, you know, science takes time.
Yeah.
And that's the difference between the reality TV shows and real, you know, having to gather the data, but also to chew on it and understand what they really mean. And so today we've had the Mars Exploration Rover. One of them is still continuing on. We have Curiosity. The ExoMars, ESA ExoMars mission is ready to go in a few days. In 2020, the Mars 2020 mission is going to leave, and for the first time in a very long time, we are going to search for life on Mars. We never actually looked for life on Mars.
Really?
One time with the Viking mission in '76, and I think this is where the disconnect is with many people, is that people think that we have been looking for life on Mars for 40 years.
I thought so.
We haven't.
Really?
No, the first one and the only one that did actually was the Viking mission. And that was the first that landed on Mars in '76. And it had an experiment, but at the time we didn't know anything about the environment of Mars. And so the result of that mission were very much debated, still are today. But starting with ExoMars and with Mars 2020, we are going to seriously look at the potential for what we call biosignatures, the signature of life on Mars.
Well, then let me ask you now, Natalie, because you've done so much research of microbial life, right? Isn't that a sign that there was or is some kind of life there?
It's, you know, let's say that the environment was favorable to life as we know it. And when I say as we know it, it's microbial life. You know that Mars is a pretty harsh desert, and you have lots of UV environment. I'm sorry, lots of UV on it. And so anything at the surface will be pretty much fried, you know, and very, very fast.
You get a serious suntan on Mars.
Yeah, the kind you never recover from. But let's say that if if things happened the way they did on Earth, and because we had a similar environment at the time on Mars, the bricks of life that we know on Earth are present on Mars. That doesn't mean that, you know, 2 equal 2, but it might. And what
so you're saying the start
is
very
the same.
Similar.
Very similar. The
Okay.
2 planets have, you know, the only difference is Mars is and was always farther away from the sun.
Right.
But at the time, we have evidence that Mars could have been, you know, like the Arctic on Earth. So, you know, there is a room for biochemistry with that. And so, to me, what's more fascinating about the idea is that at that time, too, the Earth and Mars were still exchanging a lot of material. And the 2 planets being formed...
What do you mean exchanging?
Yeah, well, so what happens when the planet forms, you know, at the time, it's by accretion of dust and rocks, and then bigger, you know, bigger bodies, comets and asteroids. And so accretion means that they are coming together and the clumps become bigger, and then you're getting a planetoid and a planet. And as this happens, you think that you have lots of big asteroids and comets in the solar system at that time that are being accreted. And when you have an impact, you have a lot of material that is being ejected.
Right.
And orbital mechanics is such that when you have something that is ejected at high velocity enough from Mars or from the Earth, it would go and may end up on
becoming part of that planet,
and
I guess.
so they have been exchanging a lot of their material.
We're talking about a jillion years ago, right?
4 billion years ago.
4 billion, okay.
4.3, 4 billion years ago.
Okay.
And so we don't know yet. First, we don't know what is life still on Earth. We don't know how, you know, what is the transition between prebiotic chemistry and life. We don't know that. The sad news is that we will never know here. We'll never have a physical sample of that transition, because everything that is older than 4 billion years has been recycled by plate tectonics, it has been recycled by geology, erosion,
so
etc.
that original evidence is gone.
It's gone. We are getting evidence that is really old, 4.1 billion year old maybe, but, you know, get to a point where we are going to hit what I call the biological horizon, because that record is gone. But let's imagine for a moment that those 2 planets, Mars and the Earth, have exchanged material. You know, early on, it might be that the response to who we are, what is our origin, is sitting there on Mars.
Is on Mars?
Yeah.
Isn't that
because Mars doesn't have a plate tectonic.
Right.
And erosion and geological activity has been a lot less active.
How fascinating to think that the origin of life the answer could be on Mars.
To me, this is one, you know, of the most exciting prospects. And if life is on Mars, it can be from, you know, that planetary exchange, or it can be a different type of life.
Right.
So you can have
alien life of some sort.
Of some sort.
Okay.
Yeah. So that we know. But if we have to have family in the solar system, that has to be on Mars. If you are going outside what we call the inner solar system, which means Mars, the Earth, Venus, etc., towards the Sun, when you're getting to the outer solar system, Europa, you know, Jupiter, etc., celestial mechanics doesn't work that well. And so if something is out there, it has to be different, which is exciting too. That will be a different type of life.
Right.
But
I have to ask you, do you think there's life elsewhere?
You know, I can tell you I believe. That's not a very scientific statement, but having roamed the Earth where, you know, I have been, I still have to find a place where life isn't. And when you are looking at the environments and that we see on Europa, on Enceladus, on even on Pluto, can you imagine the geology on Pluto? I mean, so far away, so remote from the sun. So if I have to make a statement about my belief, I said yes.
Yes. And do they look like they have big heads with really big eyes?
Oh, well, you mean that kind of life. You mean not in the solar system, okay? Not in the solar system. Advanced life somewhere else.
Yeah.
Is it Carl Sagan who said that it would be such a waste of space if we were the only one out there? So, it would be terrible to try to even paraphrase Carl Sagan, but he was very right when you are seeing the number of exoplanets that we are finding, the number that can be in the habitable zone. Is it life as we know it? Not so sure, but right now we're searching for life as we know it.
But if you had the chance to go now, would you hop on that rocket and shoot off to
On a round trip?
On a round trip?
Yes.
Not a one-way?
Not a one-way.
Yeah.
Not a one-way. But definitely on a round trip, I would be, more than interested.
Yeah.
Then the first thing I would do would get Spirit unstuck from where it is in Gusev.
Oh, it's stuck right now. Okay, you got to save that little guy. Well, Natalie, it's
became attached.
Of course you have, because he found something pretty amazing over there. Well, thank you so much for coming in. It's just fascinating work that you and other Mars explorers are working on. It's great stuff, and hopefully we'll learn more about ourselves.
I think this is one of the most exciting possibilities.
Yeah.
Is that the answer to how it happened. For us to be here, this time where prebiotic chemistry transitioned to biology.
Yeah.
Might be sitting out there in an outcrop.
Amazing, amazing. Well, Natalie, thank you so much.
You're very
Great
welcome.
Stuff. Well, in 2027, 4 people will allegedly head to Mars, the new frontier, and never come back. Now, a Filipino-American believes she has what it takes to live the rest of her days on Mars. Full Frame contributor Sandra Hughes caught up with California-based businesswoman Jamie Del Rosario to find out why she's ecstatic about being shortlisted for the possible one-way Mars One mission.
Bring in the sheets now.
Filipino-American Jamie Del Rosario is a Los Angeles-based CEO whose company supplies sheet metal to the aerospace industry. The 28-year-old is also studying mechanical engineering to get her degree. Oh, and she'd someday like to go to space.
Seeing my materials go from a processing aspect, from raw first stage to processing and then going to space or going to being an end product, being used for technology or everyday use, I said, why not me? Hi, how are you?
All kidding aside, she's a hard-charging entrepreneur who knows what she wants and is often tapping new technology to enhance her own business. She's always looking to the future. That's what drew her to the Mars One project and the possibility of going to Mars, but never coming back.
Mars One will establish human settlement on Mars in 2023.
A Dutch entrepreneur is behind the Mars One project, which it says attracted 200,000 applicants. That number was whittled down to just 100, and Del Rosario is in that group. However, critics say far fewer actually applied. As for Del Rosario, she says she's glad she did.
It becomes an idea. They're doing everything that they can right now to all go to Mars, and I think it will be executed, and I want to be the first person to be there and to land there. And if it's not me, someone will, and I want to be able to help and assist.
There has been much exploration of the red planet by a robotic rover, and the U.S. National Aeronautics and Space Administration, or NASA, has found evidence that water once existed there, but no human has ever gone. The last human exploration in our solar system was to the moon back in the 1970s. And the International Space Station is continually manned with different astronauts and supplies. But Mars? Skeptics like University of California, Los Angeles professor David Page wonder how the project will raise funds and how this first so-called colony of Martians would live.
On Mars, you'd have to live inside an enclosed environment. The atmosphere, you wouldn't last more than a few seconds. It's just like in the movies with regards to, the cold and the lack of oxygen and pressure in the atmosphere.
Commander, Mark is dead.
We have to go now.
Professor Page is talking about the latest Hollywood mission to Mars called The Martian. Actor Matt Damon plays an astronaut left behind on Mars to fend for himself in the hostile environment.
I'm still alive. Surprise.
Someone who actually goes to Mars will probably need to be selected very, very carefully and trained extremely rigorously and have, backgrounds in all the sorts of things that they need to do. I mean, the recent Martian movie sort of shows, an example of a, Mars survivor who has a lot of, knowledge at his fingertips and is able to sort of put that to work.
Critics wonder how Mars One is going to pay for the project. The flight alone is going to be between 7 and 9 months. But what about building a colony 225 million kilometers away from Earth? A reality TV show showing the various candidates readying themselves for the journey was supposed to help pay for the project. But the status of that is still unclear.
Sending a human to Mars, I don't know, $100 billion, something like that. In today's money, maybe sending a colony, many times that.
Mars One says it has investors and expects more. Jamie Del Rosario is realistic about her chances, but says she's ready for a one-way trip.
I am not coming back because first of all, it's a permanent human settlement to colonize. Second is there's no launch pad, there's no Cape Canaveral in Mars yet. When our founding fathers found this land, did they say, I think I'm going to go there and I'm going to come back?
While Del Rosario admits she'd miss her family, with no husband or kids, she says she's ready to take the trip of a lifetime. For Full Frame, this is Sandra Hughes in Los Angeles.
All right, we'll have to see what happens. We'll be right back with this week's Full Frame Close-Up. Stay right there. Art and science may seem like polar opposites, but when brought together just so, the combination can create something breathtaking. Photographer Navid Bharati has successfully done exactly that. Navid has a degree in electrical engineering, but it was his passion for photography that inspired him to travel the world working with large-scale companies. Now, one of those clients, Apple, even commissioned him to work on an installation in Chongqing, China. Navid's unique perspective has now launched him beyond this world and into space. To create these pictures, Navid uses a photo scanner and mostly edible household ingredients. On this week's Full Frame Close-Up, Navid takes us on a photographic journey of the wonders of the universe.
I think space sort of ignites our curiosity as humans. And I've always been fascinated and had a passion for space as a kid, camping out in the backyard of my tent and my telescope set up. I think science and art can definitely mix. I'm always looking at Hubble telescope images online, and I'm inspired by a lot of the astronomy photos I see every day, like a lot of different astronomy websites I go to. So when I first created my Wander project, I made up this story that I was selected to be part of the Wander mission, and that this was actually a spacecraft out there exploring the universe. And I was selected to be a part of this mission as the image processor because of my engineering background and my photography. And people actually believed that the photos were real. I had a lot of people fooled for a long time until I finally told them it was just me making it on a scanner out of food. I had seen other artists where they scan objects on scanners. And so when I was looking at these space photos, I thought, I wonder if I could do this on a scanner somehow, because you already have the whole black background of space when you leave the lid open. Like, so how can I make these stars? How can I make these galaxies or these nebulas? I mean, the stars really just look like sprinklings of sugar or salt. That might work. And then, so some stars are different colors. Maybe I'll try some different color spices. So I just started experimenting on a scanner, like spreading spices around and doing scans. And I actually was really surprised when the results came out the first time how close it really resembled the universe. So it's just been a whole series of experimentation, what spices work well, and how much, how little should I use, and then I moved on to liquids because that creates a lot of the swirls and the fluid and the gas clouds you see in space that you can't really get with just spices. And so it's been a whole experiment in progress, but a lot of fun. I want to go just sort of around the world and document the different observatories. I think observatories are they're just beautiful to look at, for one. These telescopes are massive and amazing, and it's just incredible when you think about us just peering out into the universe from these little tiny observatories around our planet, looking out into the heavens to find out, to sort of discover what's out there, discover our origins, discover, are we alone? So I want to sort of document that with a photo and photography. This is the original control panel here from 1917, actually, so almost 100 years old. So pretty much everything is controlled by this control panel here, and these eyepieces here were how they used to know where to point the telescope in the sky. Nowadays it's all done here on this screen digitally, so it was all very much analog almost 100 years ago. It's amazing to be here at the Mount Wilson Observatory, because this is where Edwin Hubble first discovered that our universe was expanding. And he also discovered the Andromeda Galaxy. So it's neat to be in this setting of so much history, so much historical significance for astronomy. So I was an engineer. When I moved from Ohio to San Diego, I literally saw landscapes and terrain I had never seen before. It looks nothing like Ohio, I saw cliffs and mountains and the ocean. It was just so beautiful and so inspiring to me as a photographer when I got there. And I think that's really what motivated me to not stop being an engineer too, because I found myself more and more passionate about photography. Like when I was at work, I just wanted to be out photographing every day. So when I moved to New York, I started doing some real estate photography. And so that actually got me access to a lot of rooftops in New York. And then because I was getting access to so many of these nice buildings in Manhattan with amazing rooftops, I decided to do this whole aerial series of looking down on New York from above. I feel like a lot of people don't get access to a lot of the buildings that I had access to and get to see New York from so many vantage points. So I guess I found an artistic project out of a professional work that I was doing to sustain myself. So Apple contacted me to do a project in Chongqing, China at the end of 2014. They wanted to bring 2 artists together from different cultures to go to Chongqing and and photograph the city for a new store that they were opening. And so they wanted to bring us together where she would do her artistic interpretation painting on top of my photograph that I took in the city. Chongqing is a special city because these 2 major rivers in China come together to form a point. And so that was really symbolic of like the theme that they had for the project, to bring 2 artists together from different cultures, because she was born in Chongqing, so she's Chinese and I'm American. I like my photos to feel almost poetic in a way, I think. A lot of people have told me that they sort of see that with my work. I want to make the viewer just feel like they're there. I want them to be able to just really feel what I was feeling. It's often when you take a photo, even I'm disappointed sometimes because it just doesn't capture like that moment that you experienced. But I want to do that as best as I can and like represent that in a photo. And I hope my work does that. And like with the Wander series I'm doing, I kind of want them to get more inspired, I guess, about space and to like think about whether this could actually exist somewhere in the universe. Just wonder if it's real or not.
And that's our show for this week. As always, join the conversation on social media. We are CCTV America on Twitter, Facebook, and YouTube. And now you can watch Full Frame on our new mobile app, available worldwide on any smartphone for free. Get the latest news headlines and connect to us on Facebook, Twitter, YouTube, and Weibo. Search CCTV America on your app store to download today. And all of our interviews can still also be found online at cctv-america.com. And of course, let us know what you'd like us to take Full Frame next. Simply email us at fullframe@cctv-america.com. Until next time, I'm Mei Lee in Los Angeles. Bye-bye.